Hi, thank you for taking the time to look at my Kickstarter project. I have created a 3D printed grand orrery. I wanted it to be different from existing orreries and have functionality that has not previously been created, even on the most expensive handcrafted brass orreries. Looking at the base, the orrery is powered by a digital stepper motor, controlled by a Raspberry Pi microcomputer. The computer is also connected to an LCD touchscreen display that will show the current date that the orrery is modelling and useful astronomical information. As we move up the orrery, you'll notice that rather than the usual two sets of stacked cogs, that they are spiralled around a central core. I think this makes the orrery much more interesting to look at. As we get to the top of the orrery, you will see that as well as the planets rotating around the Sun, there are two spacecraft rotating in an orbit between that of Earth and Mars. For this animation, the spacecraft have been greatly simplified, but for the real orrery there will be miniature SpaceX BFRs. The spacecraft are cantilevered and will pop up and down to indicate when they are in flight, one from Earth to Mars and the second returning from Mars to Earth. Let's speed the orrery up a bit so we can see the difference in orbital speed between the inner planets and those furthest from the Sun. The actual model will not move this fast, but will offer a range of speeds, with Earth orbiting between once every 15 seconds to once every couple of minutes. Okay, we'll slow it back down a bit and move down and have a look at Earth and Mars. The arm that supports Earth has 20 cogs and provide 3 different functions. The large cogs at the bottom of the arm spin the Earth at 365.24 rotations per orbit. Above that are a set of cogs which hold the direction at which the Earth is inclined constant as it moves around the Sun. This is what creates the seasons on Earth. Further cogs are driven from these that rotate the Moon around the Earth. Underneath the Earth there are 16 cogs that control Mars and the 2 spacecraft, arranged as 2 coaxial sets of 8. There are 8 cogs that drive Mars, which then goes on to drive the outer planets through further gearing, and there are 8 cogs that drive the 2 spacecraft. Driving the spacecraft was an engineering challenge, as they have to move at 2 different rates. Mars and Earth are at the ideal place for a launch every 2.133 years, so the spacecraft have to have a cycle that repeats with that frequency. Once again, thank you so much for your interest in my orrery. You can keep up to date with our products at theorrerystore.com and hashtag theorrerystore on Twitter.